Hello, grade 11s. We're going to continue on with section 2.2. Today we're going to start by talking about quadrantal angles. So quadrantal angles are angles that are in standard position whose terminal arm lies on one of the axes. So either 0, 90, 180, 270, 360, or so on. Now let's look at what sine, cos, and tan are at each of these places. And this is a little bit tricky, so try to pay close attention. The first example here is we want to find sine, cos, and tan when we're at 90 degrees. So you guys, at 90 degrees, we're looking at right here. Now at 90 degrees, the point would have a 0 for the x value and a y value of something unknown. Now the thing that's tricky here is that at 0, again we're talking about a 90-degree angle here, at 0, the r value, or the radius, is the same as the y value. That's because remember that in a normal triangle, a normal reference triangle, your r would be, again, the radius right here, and the y is the vertical height. But when this has now been moved to a point on the y-axis of 90 degrees, now the r and the y are the same. So now let's look at sine, cos, and tan. Again, my x here is 0, and my y we're calling y. So if I'm doing sine is opposite, which is going to be y, over hypotenuse, which would be r, but y and r are both the same. So y divided by r is really like y divided by y, which is just 1, because anything divided by itself is 1. Let's look at cosine then. Cosine is adjacent over hypotenuse, and then this time adjacent is 0, and hypotenuse is r. So 0 divided by anything is 0. Then we have tan. Tan is opposite, which is y, over adjacent, which is x, so 0. But anything divided by 0 is undefined, and remember that that would give you an asymptote on a graph. It can't happen, you can't divide by 0, so we call that undefined. So at 90 degrees, sine is 1, cos is 0, tan is undefined. The same process can be applied to the other sine, cos, and tan values for the other angles, so 180, 270, and 0. So at a 0-degree angle, we'd have our x value is x, our y value is 0 because it's not raised up at all. And so here the r would be the same as the x because it's lying flat. So if I want to find sine would be opposite, which is 0, over hypotenuse, which is r. So here, sine of 0 degrees would be 0. Cos is adjacent, which is x, over hypotenuse, which is r, and again, these are the same, so it's going to be 1. Tan here is opposite, which is 0, over adjacent, which you could say is x, so we end up with a tan value of 0. So again, you can apply this to the other values. 180 is going to be almost the same as 0, except it's over on the negative x direction. So over at 180 degrees, we're over here, where our x value would be negative, so I'm going to put a negative x with a y value of 0. And here, again, the r value is the same as your x. So the sine would still be 0, the cos would now be negative 1 because it's over in the negative direction, and tan would still be 0. 270 is kind of the same thing. It's going to be down at the negative y value. It's going to be down here. So again, it's going to have 0 for the x and a negative y. So 270 is going to be very similar to 90, except that sine is going to be at a negative value since it's down in the lower y's. And so those would be the quadrantal angles of sine, cos, and tan and their values. Next, we're going to get into solving for angles. So here's the steps. Step 1, determine which quadrant the solution will be in by looking at the sign. So A smart trade class, figure out where it could be. Step 2, solve for the reference angle. And then step 3, sketch that reference angle in the appropriate quadrant to figure out the standard position angle. Now that's a lot of words, so let's try one. Here we've got sine theta is 0.5, and then this part means that it's somewhere within one rotation. So the first thing we need to look at is that sine is positive. I can see that it's positive 0.5, which means it's in quadrant 1 or quadrant 2, because according to a smart trig class, it could be in 1 or 2. Next, we're going to use our calculator. So if I want to move sine to the other side, that means I have to inverse it. So we'd go sine inverse of 0.5. And when you do that, you'd get a 30-degree angle. Now be careful, your calculator has to be in degree mode, which means it might need a D at the top or DEG or something like that. But it has to be in degree mode to get a degree here. So what this tells me is that my reference angle is 30 degrees. Be very careful. The reference angle is 30 degrees. So now let's think about what that could mean for our actual answer. My 30-degree reference angle could be in quadrant 1 or quadrant 2. So if my 30-degree reference angle is here, that means one of my answers is just 30 degrees if it's in quadrant 1. If my 30-degree reference angle is over here in quadrant 2, that means the standard position angle would be 180 minus 30, so 150 degrees if it's in quadrant 2. So my answer is either 30 or 150. Let's try part B. Here we have cos is negative. So cos is negative, a smart trig class, in either quadrant 2 or quadrant 3. That's where it could be negative. So we're looking in 2 or 3. Now we have to figure out the value. So I wanted to show you one that's in exact form. So when I look at my special triangle, I see that if I'm dealing with cos, the adjacent is root 3 and the hypotenuse is 2. So that means cos would be of a 30-degree reference angle. So the reference angle is 30 degrees according to my special triangle. So if I look again, it has to be either in quadrant 2 or quadrant 3. So if my reference angle is in quadrant 2 of 30 degrees, that leaves me with a 150-degree standard form angle. Now if I'm going to quadrant 3, so all the way down here, that'd be 180 plus the 30-degree reference angle. So it could also be a 210-degree angle. So my option is either 150 or 210. However, I want you to look carefully at what it says in the question. The question says that the angle has to be between 0 and 180. So the only answer here that's between 0 and 180 is actually the 150-degree angle, not the 210. Now this next question is very similar, except you don't have a nice number, you're given a decimal number. And so we want an answer to the nearest tenth of a degree. So to start, we're going to just use our calculator. So we're going to take theta is going to equal the inverse cos of 0.6753. You do not include the negative, okay? That's because the negative tells you which quadrant you're looking at, not the reference angle. So you just type in 0.6753 and you should get 47.5 degrees for your reference angle. Now here cos is negative. So again, according to a smart trig class, cos is either negative in quadrant 2 or quadrant 3. So I'm going to look for a reference angle of 47.5. Okay, look for a reference angle of 47.5 in quadrant 2, which means that if you take 180 and subtract the 47.5, you'll end up with 132.5 for your standard position angle. Now we also need to go to quadrant 3, so I'm going to go down here to quadrant 3 with a 47.5 degree reference angle. And again, if I go all the way around here in standard position, I'd actually take 180 and I'd add the 47.5 to get a 227.5 degree standard position angle. So those would be our two answers. Try the your turn on your own and then take a look at my answers provided here and see how you do. Then we're going to move on to your textbook assignment, which is on page 96. Please try 7, 9, 10, and 12. Thanks, and have a great day.